Okay, in this video we need to learn how to name hydrates. So hydrates are actually sort of a subtopic for ionic compounds. They are actually a type of ionic compound. They're not technically just ionic compounds though. So essentially these are salts with waters attached, with water molecules attached. So the way it works is essentially you name the salt as you normally would. So name the ionic compound as you normally would. So none of that ionic compound stuff has gone away yet. And then what you do is you add the word hydrate with a prefix. So I'm going to have us learn some prefixes. These prefixes are not difficult. The hardest part, honestly, is that once I teach you these prefixes, people have this bad habit of taking these prefixes and retroactively trying to shove them in how we name ionic compounds. Please, please don't put prefixes anywhere you don't need them. Okay, so let's look at an example. So this is an example of a hydrate. So we have a typical ionic compound, and then we have this dot. It's not a decimal, it's like halfway up, which I will tell you if you ever have to use Microsoft Word to type these is in the symbols category thing. It's kind of bigger than a decimal sized dot or a period sized dot, and it's like half raised up. Okay, this is not like a superscript period. Anyway, and then it's, instead of having it as a subscript, for some reason the number goes in the front of the waters. Okay, so this is an example of a hydrate. So what we would do is we would name this part like normal, which is what I just said how to do, or what I just said to do. So this is copper. It's going to need a Roman numeral, and then SO4 is sulfate. Sulfate has a -2 charge, and there is 1 copper to cancel it out, so its charge is +2. So this is copper 2 sulfate. You'll notice that these waters did nothing to affect this. This is exactly how we named it before. To name this, it's the word hydrate with a prefix. I'll show you the prefixes in just a second. The prefix for 5 is penta. So this is copper 2 sulfate pentahydrate. Okay. Hydrates and salts without hydrates both exist. So if you took this salt and you heated it up, these waters would evaporate off and you'd just be left with copper 2 sulfate. If there is no water on the molecule, no water attached, I guess, it is said to be anhydrous. We will not start putting we will not start attaching the word anhydrous to anything that doesn't have water on it, but I will tell you that in a lab setting, you can buy anhydrous salts, and this is what it means, is there's no waters attached. Okay, before we get too far in this, let's start learning the prefixes. Most of these prefixes are pretty straightforward, and I will tell you that they come up a lot. They come up now, they're going to come up in the next video. They're also going to come up if you ever take organic chemistry. These prefixes happen a lot. Okay, so basically this number up here dictates what prefix to use. If you only have 1 water, there usually is not a number written, it's just .H2O. The prefix is mono. Okay. 2 is di. 3 is tri. 4 is the weird one of the bunch. It's tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. Technically there are prefixes that go up to like hundreds, but we only need the first 8. We'll never really go above octa. So in terms of memorizing this, which is unfortunately something I have to ask you to do, because they're never going to go away and they're going to come up all the time. Okay, so memorize this. I'm going to kind of color on this. These ones are like shapes. Like for example, this is a pentagon. If you had a six-sided shape, this is a hexagon. Same prefixes. Okay, so if you've ever learned your shapes, anything above 5 sides, the prefixes are the same. Di and tri are fairly obvious. Mono is usually fairly obvious. Most people have heard of that one. Tetra is the weird one. I'm going to draw an example that I do not need you to have memorized, but honestly, I've learned over the years that the stupider the mnemonic device, the more likely you are to remember things. So, you may have seen this before. I'm assuming that if you are, I don't know, a person, you have probably seen this before. This game is called Tetris, okay? And it's a related prefix. The reason it's called Tetris is because each of the possible shapes that you have to pile up in the game has 4 blocks. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So honestly, my mnemonic device for this is tetra means Tetris. Tetris means tetra. If you can just remember that each of them has 4 blocks, that's what the prefix 4 comes from. Okay, otherwise, this is really easy. We already know how to name salts. You just pick a prefix and add a hydrate. So prefix and then hydrate. So if we had something like, I guess I'll just make up an example. Let's say we had FeOH3.2H2O. In terms of naming this would be iron hydroxide. We would need a Roman numeral because it is a transition metal. Okay, hydroxides have a -1 charge. There are 3 of those, so this would need to be +3 to cancel it out. So this would be iron 3 hydroxide. You'll notice this water part had nothing to do with the naming. This is exactly how we learned it before. And then you just add, the prefix is di, and then the word hydrate. So dihydrate, implying that there is 2 waters attached. Okay, so that's really all there is to it. It's just a slight addition to the way we were naming salts. In terms of real-world application, hydrated salts tend to be brightly colored. So for example, copper 2 sulfate is this really pretty blue color. If you heat it until it is anhydrous, it becomes like a dingy gray colored salt, like you would envision most salts being. So they're really, really common. I'm going to tell you that from here on out, we're not going to have every single molecule have a hydrate attached, but I will tell you in the real world, they do come up a lot. Okay. All right. Thank you.